Hi there, this is Hao, and this is just another video of me solving random LeetCode problems. So let's begin. Today we have the container with most water problem. So given an integer array of height of length n, your n vertical line drawn such that there are two endpoints on the ith line are I0 and I of height I. Okay. Mm. Find two lines that together with the x-axis from a container such that the container contains the most water. So the way I understand is um this is just like the area, right? So we can have like the width multiplied by the height. Okay. We have to find the maximum amount of water a container can store. Notice that you may not select the container. Okay, so we need to always pick the shorter height. Right. So if we pick this one, the water will flow over. It has to be the the shorter one. Okay. Let's check out the constraint to see if anything helpful there. So n is the height, not length. Okay. And height of I can be anywhere from 0 to 10 to the 4th. Okay. So we can solve this problem using a exhaustive approach. We can just like search for every combination of the line, find the area, keeping track of the maximum, right? We can easily do that, but that solution have a O of n square time complexity, and I don't really like that. So let's try something else. I think we can use a two-pointer approach for this problem. So let me draw it out so that we can visualize that. One, two, three, four, five, six, seven, eight. This Y, this X. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 2, 3, 6, 7, and 8. 0 here. 3, 4, 5, 6, 7, 8. Okay. So let's draw that. So we have 0 and 1, right? 0, 1, which is this one right here. 0, 1. And then we have so by the way, we are using the first example here. 6, 2, 5, 4, 8, 3, and 7. Okay, so we have 0, we have the index here. This index. We have 0, 1, 1, 8 right here. 1, 8, 2, 6, 2, 6, 3, 2, 4, 5, 5 and 4, 5 and 4, 6 and 8, 6, 8 over here, 6, 8, 7, 3, 7, 3, and then 8, 7, 8, 7. Okay, so this is our lies from the input. Okay, so we need to keep track of the max area, right? And let's start out at 0 because it doesn't make sense to have a negative area, right? Um, and we can calculate our, okay, so we can have two pointer here, the left and the right? Starting at the two corner. So the current area can be calculated using this formula, width times height, right? Which is the area of a arbitrary rectangle. And the width can be calculated by right minus left, right? So this one we have 1, 2, 3, 4, 5, 6, 7, 8, right? So which is 8 minus 0, give us 8. Right. Okay. Multiply by the minimum of the height at left index and the height at the right index. Right. So the minimum of the left and the right. Because we don't want the water to overflow, right? We don't want we want to choose the shorter one for our container, right? So let's try that. So currently it is where we are. Uh, we are here, right? So the maximum area we can get is this part right here, right? Which is 8 multiplied by 1 because we picked the minimum height. Okay, so let's try that. 8 minus 0 multiplied by the mean of the height at left is 1, the height at right is 8, no, sorry, 7, which is 8 multiplied by 1 equal to 8, right? And 8 is greater than 0, so we update the max area to 8, right? And then after we calculated the area, we want to always move the shorter line. So for example, right now, the line at index right is shorter than the line at index left. So we want to move the index the index right because we want to find a better height, right? Because currently the right line right here is shorter than the left right line. So we have to move that in hope that we're gonna find a higher line for a better a bigger area. So we can move that here, the right here, right? So right now we're gonna have 7 minus 0. Oh, sorry. My bad. The shorter one, I'm looking at the wrong one, the wrong line. So we have the left and the right line here. Um, and the left one is shorter, so we have to move the left one, not the right one. Okay, so move the left here, left. So now we are looking at this line and that line, right? So now we're gonna have 8 minus 1, and the height as the left is 8, the height is 7, the height at 8 is 7, and the minimum of that is 7. The width is 7, right? So 7 multiplied by 7 is 49. It is a new max, so we update the max area, right? So now the right line is shorter, so we move the right line in hope that we're gonna find a higher line. So the right is here, right? So we have 7 minus 1, 7 minus 1. The mean is the height at left is 8, the height at right is 3 now, and the minimum is 3, and our width is 6. So 6 multiplied by 3 is 18, right? 18 is not greater than our max area, so we ignore that, right? And we can continue. We move the higher one. Sorry, the shorter line right here. All right. So now we have 6 minus 1, which is 5 right here. So the new height at the right is 8, right? 8 and 8 is 8, and this is 40, right? 40 is still smaller than 49, so we don't do anything. Right now we have the two line with the same height, so we could move either one, doesn't matter. I'm just gonna keep moving the right one here to the left. To the right is here, right. This is what we're looking at. So we have 5 minus 1, which is 4. And then the height at 5 is 4. The minimum that is 4 is 16. 16 is smaller than 49, so we don't do anything, right? We keep moving the right because the line at the right is shorter. So now we look at this. We have 4 minus 1, which is 3. This one is 5. Minimum is 5. It is 15. 15 is smaller than 49, so we don't do anything, right? And then we can keep moving it to the left side here, right? 2. The height here is 2. Minimum is 2. This is 2 because this is 3 minus 1. This is 4. 4 is smaller than 49, so we don't do anything. And last but not least, here, so the height at the right is now 6. The min is now 6. And we have 2 minus 1, which is 1. So the area is 6. 6 is smaller than 49, so we don't do anything. And then when we move the right pointer one more time, we will break the loop because the right pointer is equal to the left pointer. Because at this point, right minus left is equal to 0 because right equal left, right? So we don't have any area. The area will just be 0. So we just stop and return our max area. So let's go ahead and code this up. So we need a left and a right pointer. So that's left, that's 0, that's right, equal to I dot length minus 1. Need the max area is 0. Equal the max area here. Right, and then y left is less than right. We stop when the right equal to the left, right? And we're gonna calculate the current area equal to right minus left multiplied by the minimum height at the left and the right, right? So height at left, and the height at right. If the current area greater than the max area, and the max area equal to the current area, right? If the so now we update the max area, right? And then we need to move the shorter line. So if the height at left is shorter, then we move the left side, left plus plus, and else we move the right pointer to the right, so right minus minus. And that's it. Let's give it a try. Submit. And it works. So the time complexity here is O of n because we only do it in one pass. For the space, it's only constant space because I only use 1, 2, 3, or 4 variables here. So thank you for watching.